Good day, ladies and gents. Okay, so what we're doing is Unit 4 dictionary. This is on triangles. So we're starting our Unit 4 lessons. Okay, so we're going to be coming back to this dictionary a bunch of different times. So just roll with it. Okay, so I do want to explain a couple of things. But we are just going to go ahead and skip straight down here at the bottom. Down here at the bottom. Here we go. So now be careful. Some people, the bottom got cut off. So make sure that there is a 1, 2, 3, 4, 5, 6 dots here. And then also down here is number 5. So everybody should have this, but just in case it got cut off, let's go ahead and fix it. This right here should be a double or single right here. And this right here should be a double right there. And this should be number 5. And it says the third angles theorem, which goes with this picture. Okay, so we're going to go ahead and jump straight down to here. All right, so the way to prove that triangles are congruent and way of not proving that they're congruent. So up here in these little notes, there is the sides and the angles. So this is SSS, this is SAS, so that's the acronym. And this is angle, side, angle. Okay, so we're seeing those 1, 2, 3, we did those. If we go over here to the top on this little right side here, we have angle, angle, side, or the reverse version, side, angle, angle, SAA. And then right here we have hypotenuse, leg, HL. All right, so if you go around this triangle, you get ASS or SAA, which is naughty, right? That's naughty, but the better way to say that is hypotenuse, leg. So you have no idea what's going on right now. That is totally okay. You just copy down those notes. No idea what's going on. That is fine and dandy. Okay, so Mike, nope, Mike, nope.
Oh, I got a question about this.
Mike, you're not supposed to have any questions.
You're not supposed to have any questions.
I'm doing a video, sir. I told you to wait at the very end until the end of the video. Okay, so you just gotta chill just for a minute. I'm sorry, you just gotta wait. Okay, so so you don't know anything of what's going on. You're just taking notes. No worries. Okay, so congruent triangles. So there were 2 bad ones, very, very naughty ones. Now I said a word, I spelled out a word that you were like, wait a minute, that's naughty. So we want any combination of the letter A and the letter S, but with 3 letters. So ass and ass backwards are the bad ones. So you're always going to remember the bad ones first. So ass and ass backwards, that's one of the bad ones. And the other one is your ass is so big it's a triple ass. So these 2 are the 2 bad ones. Every other combination of A and S is good. So side, 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 so SSS, SAS, ASA, and AAS or SAA. So every other combination is good. Every other combination is good. Now, the only time that you can have an ass is if you have a leg, hypotenuse leg. That's kind of funny, right? So if you go around the triangle and you got ASS, if you went around the triangle, you have no idea how to do that yet, but if you go around the triangle and you get ASS, so angle, side, side, then your fallback is, wait a minute, is this hypotenuse leg? Is this a 90-degree angle hypotenuse leg? So that's a fallback. Okay, and then finally, CPCTC. CPCTC, we're going to put that in a box. So once you prove that the triangles are congruent, you might have to go an extra step and say this little part is equal to this little part. Okay, so once again, you have no idea what this means. What I need you to know is this chart, what it's, these letters. So we're trying to memorize these letters. That's it. That's all we're doing. So ass and ass backwards, and your ass is so big it's triple ass. Those are the two bad ones. Every other combination is good. Okay, and then the other way to prove the triangles are not congruent is the order is all messed up. And the last part is not enough info. Okay, so one more time, you don't know what any of this means. I'm not teaching that to you until next week, but I need you to start memorizing this chart. So I don't want to go into what these stand for yet because you're not going to really use it for a week, but I'm going to go ahead and let it simmer in your brain. So there we go. So you're just going to just have that chart there. No idea what it means yet. Just let it simmer. Okay, so there's that. Okay, let's go ahead and go on to the back page so we're going to go to page 2. We're going to page 2. Okay, so we're going to page 2, and we want to note it. We want to focus on what we're doing today because we don't care what we're doing tomorrow yet. We're just doing what we're doing today. All right, so classifying triangles. So classifying triangles by their angles. So there's 2 ways how to classify triangles: by their angles or by their sides. Okay, if you're looking at the angles, an acute triangle, that means all 3 angles are less than 90 degrees. I'll zoom back in, sorry. So all the angles are less than 90 degrees. Okay, a right triangle, one of the angles is 90 degrees. Obtuse triangle means that one of the angles is greater than 90 degrees. It's between 90 and 180. And a fourth one is equal angular, that all 3 angles are equal. And if they're all equal, they would all have to be 60 degrees. So technically, this is an acute triangle, but the better word for this is equal angular. So like a square technically is a rectangle, but a better word for that would be a square. So yes, this is an acute triangle, but the better word for this is equal angular. Okay, so what if you were given the sides, but I wanted you to classify it by the angles? So if I gave you the sides, so I know you know how to do a squared plus b squared equals c squared, but you want the c on the left side for reasons. So c squared, how does that compare to a squared plus b squared? If c squared is less than this on this side, then that would be an acute triangle. If it's equal to, it's a right triangle. If it's greater than, it's an obtuse triangle. And then finally, classifying by the sides. Okay, equal angular triangle. So my little triangle got cut off. Here's my triangle. So equilateral. So L, equilateral. That's where 3 sides are equal. Isosceles triangle, where 2 sides are equal, and scaling triangle, where no sides are equal. Okay, so you see the word sides? You can break that down. So S, I, and E, see those letters are in there. So that's how you can remember what the names are. So E, I, and S. All right, so let's look at this. So E, I, and then my S got cut off right here. All right, so check this out. When you look at the E, there are 3 horizontal lines. So that means that 3 sides are equal. I has 2 horizontal lines, so 2 sides are equal. And S, there are no horizontal lines when you write the letter S, so no sides are equal. So every single side is different. Okay, so there's a bunch of other notes on this page, but we're not dealing with them today, so we're not going to take them today. All right, so if you need to make a screenshot of this before we move on, that would be great. All right, sweet. Now we are going to go to page 3. We're going to go ahead and go to page 3. So classifying triangles. So on page 3, classifying triangles. Okay, so 3 acute angles. So so I'm just having my notes sitting right here next to me to help me out. So when 3 angles are all acute, guess what this is called? So for the angles, remember we're talking about angles. There's an acute angle, right? So that's an acute triangle. So obtuse. So 1 is obtuse, so that's an obtuse triangle because one of these angles is greater than 100 is greater than 90. Obtuse triangle. Okay, right angle. So one of these angles is right, so that's a right triangle. And I just draw a triangle shape so I don't have to keep writing the word. And then 3 congruent angles. So all 3 angles are the same. So if all of the same, then they would all have to be 60 because they would add up to 180 degrees. And that is an equal angular triangle. So if we're basing it by the angles, it would have to be equal angular. If we were basing this off the sides, it would be equal lateral. But this is equal angular. All right, so let's talk about this. All right, so we're going to be talking about this, and they said classified by the angles. So when they say classified by the angles, I usually write the words off to the side, but it's kind of right here at the top. So acute, obtuse, right, and equal angular are choices. Okay, so triangle CDE. CDE. So, and I just keep hitting those letters over and over again, CDE. So I'm looking at this triangle right here, this triangle. Okay, so if I just focus on that one triangle, where this is C, there's D, and there's E. CDE, and look at that, E. E is special. E is a right angle, so that means this is a right triangle. All right, let's go to the next one. BCE. So that's this one right here. So BCE. All right, so I'm looking at this right here, and one of these angles stands out. So B is definitely acute, E is definitely acute, and then C, if I look at that, see that straight line? See, it's kind of, that's open. So C is my special one. That is obtuse. So that's an obtuse triangle. All right, let's look at A, B, E. And you see how they all are single angles right there, A, B, and E? All of them are single, so that means that they're all the same. So that means that this would have to be 60, 60, and 60. So if they're all the same, then that right there is equal angular. It's also equal lateral, but we're classifying by the angle, so equal angular is our answer. Okay, and then finally, B, D, E. So B, D, E. All right, so right here, all right, so right here, E, so we're talking about this entire thing right here. So just to help you a little focus right there. Okay, so part of it's 90 degrees, but it extended bigger than that 90 degree angle. So that's bigger than 90 degrees, so that would be an obtuse triangle. That would be an obtuse triangle. So what letters stood out? So E stood out on this one, C stood on this one. Actually, all 3 of them were the same on that one, and E stood out on this one. So I went ahead and underlined those so I knew I made these decisions by these particular letters. That just helped me out. Okay. All right, let's go ahead and classify by the sides. So sides. So S, I, and E. So there is, so when three sides are congruent, then that is equal lateral. Equal lateral. So all 3 of these sides are equal, so they all have single notches. Only 2 sides are equal. See the notches? Only 2 of these sides were equal, so that would be isosceles. So isosceles triangle. And then no sides are congruent, so that's scalene triangle. That's a scalene triangle. Okay, so on this one, okay, so J, K, and L. So J, K, oh, and M, J, K, M. So that's a whole shebang right there. So just focus on that. So J, K, and M. So J to K is a single. K to M, there's a double and a nothing. So I'm not going to mark anything on that one because there's nothing really there. And then J to M has a single and a nothing. So, and I don't know anything about those nothings. So I don't know if any of this is equal. So that answer would be a scalene triangle. All right, so let's look at the other one. We have K, L, N. So right here. So I'm just drawing this here so that you can see what's going on in my head. So on this one, we have this side and this side are equal. So we have a double double and then a single. So the doubles, we have two doubles. So that means they are the same. So that would be isosceles because two sides were equal. And finally, J, K, N. So right here. J, K, N. So J, K, N. Boom, boom, boom. So three sides were equal. So that's equilateral triangle. All right, sweet. Okay, hopefully this is just starting to sink in, starting to make a little more sense here. All right, number 8. Number 8, so this time they want angles and sides. So we have to do in that order. So the first thing we have to classify is by the angles, and the second thing we have to classify is by the sides. Okay, so angles. Okay, so look at the angles. We have a 90-degree angle, nothing, nothing. So that would be a, that right there would be a right triangle. Okay, so that's just by the angles. Let's just continue. So we classify that by this angle right here. This one, if this is 114, so that would be an obtuse triangle. And then this right here, 60, 60, 60, equal angular triangle. So we just classify that by all of the angles. Okay, so now let's classify by the sides. Let's go back. How many sides are equal? So that would be two sides are equal, so that's isosceles. Okay, so it's a right triangle and an isosceles triangle at the same time. This one. All I know is that this is 114. So I only know that angle. I don't know anything about the sides. I don't know that these two sides are equal. I have no idea. So I have to classify this as scalene because I don't have any proof. And sorry about my ugly, ugly triangles. Okay, and then finally, 60, 60, 60. If the three angles are equal, then the three sides would also be equal. So this is equilateral. So when it is an equal angular, it would automatically be equilateral at the same time. Okay, we have one more page to go. Okay, let's look at page 4. Looking at page 4. All right, so looking at page 4. Okay, so what we're going to do is we're going to draw these triangles. All right, so let's plot it. So -7, -7. That's my A. -9, +1. That's my B. -1, -1. That's my C. And then I would take my straight edge, connect the dots. Okay, so here's my triangle. Now looking at this, now they told us that they want to classify by the side, so we need to find the side lengths. All right, so this is important. This is going to be very important on your test. So to find the side lengths, I would probably just use this right here. So I trained you guys to do it by the numbers, but you can also do it by Pythagorean theorem. There's pros and cons to everything, so you just do what works for you. Okay, so if I go A to B, B to C, and A to C. All right, A is -7, -7. B is -9, 1. All right, B is -9, 1. C is -1, -1. And A is -7, -7. C is -1, -1. All right, so distance, what we would do is we would subtract the numbers. Remember that? we subtract the numbers. So we're doing -7 minus a -9 and -7 minus 1. So we're subtracting the numbers. So I'm going to grab out my calculator. -7 minus a -9, and I would get 2. And over here, -7 minus 1, you would get a -8. So what we're saying is from A to B, so A to B right here, we have a 2 by 8 triangle. 2 by 8. That's what we're doing. And I agree with that. That's 2 hops and that's 8 hops. That is correct. All right, so 2 squared plus -8 squared. So we got 4 plus 64. And you get square root of 68, and you would just leave it as the square root of 68. All right. All right, let's do this one over here. So I showed a lot of steps here, but now I'm going to skip some steps. -9 minus a -1, I would get a -4. 1 minus a -1, we would get a 2. So what we're saying is from B to C is a 2, I'm sorry, -9 minus -1 is a -8. So I caught myself. I said it was a 4 by 2. That's definitely not 4 by 2. So I double checked it again. Oh, I subtracted it wrong. So that's an 8 by 2. So I caught myself by going like, okay, I got this number and then make sure that made sense. It did not. Oh, caught myself. All right, so that's an 8 by 2 triangle. I agree. So I would square those. So 8 squared is 64. 2 squared is 4, and we got the square root of 68. All right, so far so good. And you can just leave it just like that. Okay, and then same thing over here. -7 minus -1, -7 minus a -1. So -7 minus -1, we would get a -6. -7 minus -1, we get -6 again. So we're saying it's a 6 by 6 triangle. Yep, that's 6 hops, that's 6 hops. So I agree. So it's a 6 by 6 triangle. Square those, and we get 36 and 36, which is, so 36 plus 36, you get the square root of 72. Okay, and we can leave it just like that. Okay, so by just looking at this, based off the sides, what kind of triangle is this? Well, I know that these two are equal to each other. So that means it's an isosceles triangle. And there's your answer. Okay, now what if we went a step further? So this is a little extra piece. This is a little extra. We're just doing something a little extra. What if I said classify by the angles? Okay, so if we look back at our notes, to classify by the angles, all right, so to classify by the angles, but we're given the side lengths, we want to know how does c squared compare to a squared plus b squared. So how does c squared compare to a squared plus b squared? So we're going just a little further, guys. Okay, so how do you do that? Well, c squared would have to automatically be the biggest side. And the biggest side was the square root of 72. So square root of 72 squared, how does that compare to this squared plus this squared? So how does it compare to square root of 68 and the square root of 68? All that squared. I'll zoom in. Okay, now the reason why we didn't simplify this earlier is because of this part right here. When you square a square root of square of a square root, they cancel each other out. So how does 72 compare to 68 plus 68? How does 72 compare? 68 plus 68, you get 136. And this is less than. So, and I said less than, right? So that would be an acute triangle, which looks legit, doesn't it? All these angles look like they're less than 90 degrees. We were just making sure it's not like all three angles are the same or anything like that, right? Okay, so we know this is an acute triangle. Okay, so let's make sure we answered their question. So I just gave you this little extra part just for the heck of it. All right, so let's check. They said give by the sides, and they want the simplest radical form. So our final answers were by the sides, it was isosceles triangle. And what were the side lengths? Okay, so we have the square root of 68. So I'll write this here. Square root of 68, square root of 68, and the square root of 72. So we have to simplify that. All right, so you remember your list of squares. We had, okay, so we had 2 squared, which is 4, 3 squared, which is 9, 4 squared, which is 16, 5 squared, which is 25, and I would just keep going, right? 49, 64, 81, 100. Okay, so I want to know what the biggest square I can take out of 68. So I'm going to take, so 68, so I would try to take out 64 because that's the biggest number without going over, right? So if I do 68, if I divide by 64, that's not a pretty number. Okay, if I try 68 divided by 49, that's not a pretty number. Okay, let's try 36. 68 divided by 36. Nope, that doesn't work. How about 25? Nope, that's a prettier number, but it's still not a whole number. Okay, how about 16? 4.25. Nope. How about 9? Nope, that doesn't work. And finally, our only last chance is 4. So divide by 4. There it is. So 4 and 17. So that is really the square root of 4 times the square root of 17. So you always put the square in the front. All right, what's the square root of 4? The number 2. So 2 square root of 17. So square root of 68 is really 2 square root of 17. All right. Oh, we already did that one. So square root of 4, square root of 17. So that's 2 square root of 17. And finally, 72. Let's do it again. You would just keep dividing numbers, and I'm pretty sure 72 divided by 36. Yep, 36 is the one that works. So square root of 36 times the square root of 2. 36 times 2 is 72. 36, that is 6 square root of 2. So from least to greatest, our answers are the side lengths were 2 square root of 17, 2 square root of 17, and 6 square root of 2. And how are you guys going to type that into the computer, like in the chat or in Teams? I'm okay with you guys just using the question mark. So 2 question mark 17. That's what we're just going to use because we don't have the actual button for that. Okay, let's go ahead and go to number 12. Okay, let's plot the points. So -3, +2, 2, +6, and 8, -1. All right, so let's go ahead and draw that. All right, so we have X, Y, and Z. X, Y, and Z. Okay, so just looking at this, you can probably make a good guess as to what it is. So based off of the side lengths. So, but let's actually do it mathematically. So we're going to do X and Y, Y and Z, and X and Z. All right, so we have -3, 2, and 2, 6. We have 2, 6, and 8, -1. And X is -3, 2, and Z is 8, -1. All right, so I found I'm going to find all these little side lengths. Okay, so what we do is we subtract the numbers. So -3 minus a 2 and 2 minus 6. So -3 minus 2, we get -5. 2 minus 6, we get 4. So if we look back over here, okay, so we're making these little right triangles. Okay, so x to y, see the right triangle right there? We're saying that this is a 5 by 4 or a 4 by 5. So let's check 1, 2, 3, 4. 1, 2, 3, 4, 5. So yeah, I agree. It's a 5 by 4 triangle. So you would square that. So we're doing Pythagorean theorem. So that'd be 25 plus 16. So 25 plus 16, we would get 41. And we have the square root of 41. Okay, over here, we would do 2 minus 8, which gives us a negative 6. 6 minus negative 1, which gets us a positive 7. So we're saying from y to z is a 6 by 7 or a 7 by 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So yes, I agree. We would square those. So we get 36 plus 49. And we got this, we have 85. So square root of 85. And then finally, over here, negative 3 minus an 8, we get a negative 11. 2 minus negative 1, we get a 3. And we're saying that this is 11 by 3 triangle, so x to z. So let's see, 1, 2, 3, yep. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So yes, it's a 3 by 11 triangle, just double checked. 11 squared is 121. 3 squared is a 9. Add those two together, and you get 130. Okay, so now notice that all of these are different. All of them were different. So I feel really good about this. So this would definitely be a scaling triangle because all of them were different. Okay, now if they asked us to go a step further and make it pretty, okay, I'm going to do that over here. Square root of 41, square root of 85, and square root of 130. Okay, 41, I would divide all these numbers out. Nothing worked. So square root of 41 was done. Square root of 85, I would try 81. That's a decimal. I would try all these numbers. None of these numbers, when I divide by these numbers, none of them would end up as a whole number. And same thing with 130. So I was stuck with all of these. So my side lengths from least to greatest was the square root of 41, square root of 85, and square root of 130. So none of these could have been made simpler. Okay, and that would have been our answer. Let's go an extra step. So this is extra. What if I said to classify by the angles? Okay, so we would do c squared. How does that compare to a squared plus b squared? So from least to greatest, right? So the biggest number has to be our c. So our biggest number was the square root of 130. So we're going to do the square root of 130 squared. How does that compare to square root of 41 squared plus the square root of 85 squared? Okay, so the square root and squares cross each other out, 130. How does that compare to 41 plus 85? So 41 plus 85, we would have 126. And look at that. This one is greater. So this is an obtuse triangle, which does look legit because y is greater than the corner of my paper. See that? It's just slightly bigger than the corner of my paper. So that is obtuse. So it was like, is that a right triangle or is that obtuse triangle? And it was obtuse. So we did an extra step. Okay, so now what you guys are going to be doing are pages 5 and 6. Okay, so as long as you get page 5 done, I'm happy. All right, so this one, they're asking for you to classify by the angles. That's the first question. And the second question is classify by the sides. So that would be the first thing. Okay, over here, let me help you get a little started here for number 5. And then I'll leave you guys be. All right, so P, Q, R. See that? All that right there. So P, Q, and R. I know that P right here is 60 degrees. I know that R right here is 90 degrees. 60 degrees. So both of these are 60 degrees right here and here. So what would be left over right here? That would be another 60 degrees. And if all three angles are equal, what do you know about all three sides? Okay, so that should help you out there. And then finally, PRT, right down there. So this right here, PRT. Okay, if this is 60 degrees here, what's left over to make a straight line? That would have to be 120 degrees. So this right here is 120. I don't know what this angle is. I don't really know what this angle is, but that should actually give you enough information right there. So what kind of triangle is that? Based on the angles and then based on the sides. Okay, so it's your job to finish this. Hopefully that was good enough notes for you. Have a great day.